Self-organizing map, SOM. SOM is a kind of neural network, which was proposed by Koanen, and SOM can extract the feature on the multidimensional input vectors and can visualize the relations among them by unsupervised learning. SOM can integrate multimodal input vectors and can extract relations among them in two-dimensional plane. SOM can be used for clustering of unlabeled data or classification of labeled data with labeling the output units after learning. Shows the basic learning algorithm of SOM. For each input vector, the neuron, which is closest to the input vector, is searched from the neurons which are arranged on the two-dimensional map. The closest neuron is called as winner neuron. The winner neuron and the neurons in the region of the neighborhood are updated as to decrease the difference to the input vector depending on the learning rate and neighboring functions. These steps are iterated for each input vector with decreasing the region of the neighborhood and learning rate. Schematic description of SOM algorithm. Application of SOM to the authentication system using handwritten patterns. Recently, many mobile devices, such as smartphones, tablet devices and small computers, are equipped with touchscreen. As the authentication method for touchscreen devices, the password authentication is often used. But, on touchscreen devices, password can be looked while typing on the screen. It is troublesome to enter the password using handwritten character recognition or screen keyboard. For the touchscreen devices, handwritten signature authentication is often applied, because the touchscreen is considered to be useful for signature input. However, the shape of the signature may be copied, and it is difficult to write the exact signature on slippery screen, especially for people who do not usually write signatures. For this problem, we propose a user authentication method using the identical symbol for all users. Using this method, the symbol which is used for authentication is displayed on the touch screen and users simply trace it. However, the pin stroke data may not be enough for user authentications. We use the pin pressure data which may have enough information for user authentication. For this purpose, we analyze the pin stroke data and pin pressure data using self-organizing map. Test input screen. Pin input of symbol star. Shows the screen of the application which measures the pin stroke data and pin pressure data of symbol square, circle, triangle and star. Each symbol is written in a single stroke, and starting point is specified for all users. 5 samples are taken from each of 12 users. Shows an example of symbol star taken from a user. This sample contains 232 points of x-axis, y-axis and pin pressure data in z-axis. Organized map for simple symbols. Shows the maps of each symbol. The numbers in these figures denote the used ID. With these figures, the symbols of circle and star show better separations compared with others. We consider that the symbols comprised of oval lines or acute angle have more specific features of each user. The symbols of spiral and complex star are selected for next experiments. Organized map for symbol spiral and complex star. Shows the maps of the symbols spiral and complex star. We use the torus map for this analysis, so the upper side of the map is connected to the lower side, and the right side is connected to the left side. Both of the symbol star and spiral show better separations compared with the simple symbols. It will be possible to authenticate the user using pin pressure data and pin speed data. The authentication experiments using these symbols are conducted. As the authentication system, we use SOM. The settings of the experiments are as follows. 10 samples of spiral and complex star were taken from each of 10 users. 7 samples of each person were used for training SOM map, and 3 samples were used as test data. The maps were retrained by LVQ3 algorithm. Results of authentication experiments. Table 1 shows the result. For the learned data, both of the spiral and complex star show high rate of authentication and low rate of false acceptance, but for the test data, rate of successful authentication was about 70%. From the table of spiral test data, users 6, 9, 10 show low rate of successful authentication, and from the table of star, same users are not authenticated at all. Both of the symbols can authenticate 7 users from 10 users. It depends on the characters of the users. The careful users tend to be authenticated better and careless users tend to be rejected falsely.